Hey, Hess's Law Part 2, okay? Again, we're trying to figure out the heat associated with a reaction. Knowing the delta H's, the delta enthalpies, the change in enthalpies for other reactions. So we want to be able to use these to determine this, and then we can just simply add up the delta H's. All right, so let's take a look at where are we gonna start. 1 and 3 both have oxygen, so I would stay away from one. I would stay away from, just simply multiplying this by 5, because we're gonna have to account for that oxygen. So those oxygens will work out on their own. If you think about the equation 1, there's 2 NOs here and there's 4 there, so we can simply multiply equation 1 by 2. If you think about this one here, these NH3s, they're a product, so we could flip that, multiply by 2. How about reaction 3? What do you think we'll be doing with reaction 3? So see, we have 6 H2Os. Just multiply by 3, right? All right, well, we'll start with reaction 1. It doesn't matter what you start with. Doesn't matter. So we're going to take 2 times reaction 1, all right? 2 times reaction 1. So here we go. 2 times 1. So we have 2N2 plus 2O2 yields 4NO. So if we have double the reactants and products, we'll have double the delta H. So I'm going to do 2 times the delta H for reaction 1. Okay? All right, reaction 2. What are we going to do? We got to reverse it and multiply by 2. So I'm going to say negative 2 times equation 2. That product's going to become a reactant. We're going to have 4 NH3s yields 2N2 plus 6 H2. And that's interesting. There's no hydrogen even in this, so it's got to cancel out. It's got to cancel out, and you'll see it'll cancel out. So we're going to take negative 2 times delta H2. All right. So far, we have this is what we want, and this is what we want. Anything cancel out so far? Yeah, look at that. That cancels out. So you can start cleaning it up here if you like. All right, reaction 3. We're looking at those H2Os. We want 6 of them. Let's multiply this by 3. So we're going to take 3 times reaction 3. So we got 6 H2s plus 3 O2s yields 6 H2O. We're going to take 3 times this delta H. All right, if we add those up, that should give us that. And let's see, there's 6 H2Os, so this is good. Look at this 6 H2s. They cancel out with these. How about 2 O2s and 3 O2s? That adds up. They're both reactants. Adds up to 5. That's exactly what we want. So if we add these up, we would get this. So then what we can do is simply add these up. So I already did that. I have it on my calculator. Let me just check here. This should give you negative 1,628.2 kilojoules. Just be careful with these units. Sometimes it could be kilocalories, calories, joules. In this case, it's kilojoules. That doesn't even look like a J, does it? This reaction's exothermic. So that's part 2. So that's Hess's Law. I'll give you something to practice with. You can reverse the reaction. If you do that, take the negative of the delta H for that reaction. You can multiply a reaction by any integer, by any fraction. You can multiply it by a third, multiply it by half, a fourth, multiply it by 5. But when you do that, you need to be able to add them up, and it needs to give you the overall reaction, okay? All right, good luck with that. It's going to take you a little bit of practice, okay? This will be due Monday, probably. Okay, bye.